We looked at this just before in the previous short, where the subsurface warm anomaly seems to be moving eastward from the west. You can see that it propagates and it's heading towards the east, where it can surface and cause that warm SST anomaly, sea surface temperature anomaly, which can then start the feedback by reducing sea level pressure here, increase sea level pressure there, winds, further weakening the upwelling and further warming and so on. So where does this warm water actually come from? Remember the normal conditions where trade winds are blowing on the surface from the east towards the west. They are pushing water away from the equator and pushing water towards the west. Cold waters are coming up. They are soaking up heat. So the tropical Pacific is accumulating warm water in the west and around it, almost to, let's say, 10 degrees south and 10 degrees north. A warm pool of water is being built up. Sometime during some part of the year, typically end of the summer, this water gets released. It doesn't just start here. Because the water is spread out in a latitudinal direction, the thermocline tilt happens also in the latitudinal direction, and the warm water begins to congregate towards the western Pacific, and then the tilt happens in the east-west direction, so that water then begins to travel eastward. The entire thing raises a question about whether this so-called recharge and discharge is a fundamental process to El Nino. Recharge is because the ocean is upwelling, soaking up heat, and accumulating it in the west and West Pacific and towards the higher latitudes in the deep tropics or tropics, and that is the recharge phase, because you are recharging the ocean with this warm pool of water. Discharge is when the process begins of meridional tilt and the zonal tilt, and all that warm water begins to move towards the east where you had cold waters before. And once this process is complete, you obviously have all that heat being released to the atmosphere. Global mean temperatures can go up, and we call it mini global warming during an El Nino. But because of the moving heat sources, it also creates global weather perturbations, which we call teleconnections. And monsoon is, of course, one of the more famous teleconnections, but you also have droughts and dust storms and wildfires over Indonesia and Australia. You have impacts on East Pacific, South Pacific, on South America, North America. It depends on the season and so on and so forth. So we can look at that as we go forward, but just to look at this animation again, you can see the clear eastward propagation of this subsurface warm water anomaly. Later on we will see how this ends and where the water to replace this will come from. But we can look at this in terms of a preconditioning of El Nino events. One thing we haven't answered yet, a key question. El Nino happens every few years. Does that mean it's an oscillation? If it's an oscillation, then why doesn't it have a regular period? Why doesn't it happen every few years at the same frequency? Why does the number of years between El Ninos change? We had 2015-16 El Nino, 24 El Nino. Now already in 26 we are having another big El Nino. Before that we had 2009 and so on and so forth. So the periodicity is not constant. If it is not an oscillation, then does it need a kick, a trigger? And if it needs a trigger, then it's like a damped oscillator. That means something kicks it. It goes warm and then goes cold, or during La Nina it gets cold and then may get cold again in the next year. We saw that La Ninas can survive multiple years, right? So here we are looking at the sea surface temperature anomaly in the tropical Pacific. When it is cold, it's a La Nina. When it's warm, it's an El Nino. And you can look at discharge state, which means the depth of the thermocline averaged over the tropical Pacific from east to west, 5 south to 5 north, can be considered as a recharge stage when it's positive, so it's accumulating heat. It's a discharge state when it gets shallower. Remember, we looked at the El Nino state and the normal state. Even though it's tilted east-west during normal conditions and La Nina, the entire thermocline average across the tropics is actually deeper with warmer waters, whereas during El Nino it expands the warm waters and gets shallower. So you are in the recharge stage here with positive thermocline anomalies, discharge state here, and you are in this phase space of El Nino and discharge, La Nina, and recharge, but you have to transition. So you can look at November, see 97, 98, El Nino, for example. It starts somewhere here in, let's say, in a mild La Nina state during some part of the year. That was like, let's say, spring of 1997, and it begins to discharge, and it expends its energy, and the La Nina state is there, but it begins to, sorry, we are coming out of the end of El Nino here. So El Nino has finished, and it is in a discharge state. It finishes the discharge, begin to recharge, so then it comes here into the recharge and El Nino state. So for an El Nino to happen like now, there is a recharge state that is ready to discharge, which is what we are looking at here. So discharge is happening, recharge is not finished yet, discharge is going on, and the discharge happens and you begin to be in the warm state, but you slowly go towards the cold state because you expend all that warm water. So we saw that before here, the transitions here, for example, El Nino, and then cold state comes. So here discharge is finished, and this is the recharge phase. Okay, I'm maybe not doing a great job, but try to imagine the whole cycle. Okay, so this is what it is showing, and it is basically saying that there is a phase space where El Nino is ready to go when it is recharged and thermocline is deeper, warm water has accumulated. Something happens, we don't know exactly what, like exactly why the El Nino this year started, nobody can tell you. Once it starts, there are some other things that can make it grow, like if the trade winds got weaker, then upwelling gets weaker, warm SSTs appear near the coast of South America as they have done already. That warmer SST in the east reduces the sea surface temperature gradient, pressure gradient, weakens the winds further, weakens the upwelling further, and you have El Nino growing. That's what we call a positive feedback, and that positive feedback has to end sometime, and warm water is discharged, then it will end, then the recharge will start again. Okay, so looks like there is a preconditioning of ENSO events with the recharge state, but this is like explaining what is happening in the past. It doesn't necessarily give you a prediction ability based on recharge discharge, because discharge starts and we see it after it has started. The question is exactly when does it start? Okay, I'll just say this and then we'll come back. So you can see that the March, April, May, as we said, entire tropical Pacific gets warm, sea surface temperature gradient gets flat, and then as we get into June, July, August, the La Nina state may emerge, so you get colder SSTs before you come back to the next spring, or it may be normal conditions, so June, July, August will be upwelling, so it'll be colder. But when it's an El Nino, spring ends, upwelling begins to seem to want to start, but then it goes into a warm spring state, and then it just goes into a warm state instead of going into La Nina or normal conditions. So looks like the system knows something here, whether to go here or here or here. What is it that it knows? Is that something very fundamental to El Nino? This is a key question. Somebody has tried to answer it, but that's not obviously a universal answer. We'll come back and look at it in the next podcast, but just try to remember these buzzwords: discharge, recharge, oscillator, decay, stable oscillator, but periodicity has to be explained. Damped oscillator, which means it needs some kind of a kick every time, and so on. So many deep questions unanswered, okay?